So this is all review. So the first thing we're going to look at is our rate of change. Does this one have a constant rate of change or a variable rate of change? Constant. If it's linear, that means no matter what, I'm going to have the same rate of change. So put that under the graph. Constant rate of change. So we're on the linear section. We're starting from that. Next thing we're going to look at is the slope. So did anyone find the slope?
-2.
2x plus 8.
Since it's going up,
2.
it's a bias. I was trying to say two different things at once. Since it's going up, it's going to be a positive slope. I can also just pick 2 points like this and go, okay, it goes up 2 over 1, up 2 over 1. So my slope would be 2. I know, it's a 2 though. Who can raise their hand and tell me what the y-intercept would be? Alana, go for it. Beautiful. So it's what falls on the y-axis, so it'd be 0, 8. Remember, zeros are your x-intercepts. So who can raise their hand and tell me, Derek, what's the x-intercept here? Beautiful. -4, 0. So make sure you're filling this in. -4, 0. Now, Jeremiah, what's the slope-intercept form of this equation?
2x plus 8.
Beautiful. So our 2 is our slope, our 8 is our y-intercept. So you guys just did this basically with a table on your test. Wait, standard form. I'm just having you. What is standard form? What's the equation? A what?
X plus by.
Yeah. Ax plus by equals c. I'm not making you do that over here. Ax plus by equals c. For a brain bug, who can raise their hand and tell me what parallel lines means? Divine. Like when something's parallel. Or you can call somebody. Okay, Ariane. They never touch. Good, that's one thing. They're equal distance apart, never touch. If I'm looking at an equation for another brain box, who can tell me what is the same about the 2 equations if they're parallel? Something's the same about them, Jeremiah.
Slope.
The slope. So parallel lines have the same slope but different y-intercept. We haven't gone over that in a while. Same slope, different y-intercept. So, Divine, give me any equation that would be parallel to this one. This equation. If it's the same slope, different y-intercept. Give me any equation that would be parallel to that one.
Is there one?
No, just give me, you can make it up.
2x plus 5.
Sure. Y equals 2x plus 5. As long as it has the same slope and different y-intercepts, they're parallel. Oh, I have a few. Cool. Perpendicular. I don't. Did we go over that?
No, I don't even know what that is.
Perpendicular. I don't know. Sometimes I saw it in Florida. It's in algebra standards, but I don't think it's in. I don't think it's in yours, but it's opposite reciprocal. But we don't need to deal with that for right now. Next, is that increasing or decreasing? Increasing. Increasing, right? Because it's going up. So this is increasing. Just put it somewhere on this little on your pink sheet. It's increasing. What's the domain of this?
-5.
Beautiful. Domain is negative infinity, positive infinity. It's going in both directions forever and ever. What about the range?
-10 to negative.
It's to infinity. It's negative infinity to positive. If it was like a dot right here, which it actually, it's not an arrow, but I would like it to be an arrow. If it was right there, Jordan, and that was a dot, it would be negative 10. But I'm making it an arrow. So since it's like that, it's negative infinity to positive infinity. But that wasn't wrong. Cool. And we know that the rate of change is constant. Awesome. Okay, let's go to exponential now. And so they even give us the equation right here. Who can raise their hand, tell me the y-intercept? Valeria. Beautiful. 0, 2. Who can give me the growth factor? Either by looking at the equation or looking at the graph. You can get it either way. Kayla. 3. So I can either look at the equation. I know some people are struggling when making your equation. That's what it's being multiplied by, that middle number, 3. Or I could go, okay, it goes from 2 to 6. From 2 to 6, what do you need to multiply 2 to get 6?
3.
3. Asymptote. Do we all remember that?
Zero?
Zero.
Is it zero?
When x equals 0. Asymptote is the end, the rear end. And we can see right here, it's when x equals 0. It's where the plane lands.
Why is the point on top?
I was just showing you from 2 to 6, you have to multiply 3. You don't need to put that in. Domain, what's the domain of this guy? Yep. Negative infinity to positive infinity. What's the range?
Negative infinity to zero.
Opposite. 0
Oh.
to infinity. Because if 0 is the smallest to infinity, if it was like this divine, like that, then it would be negative infinity to 0. But because 0 is the smallest it is, it's 0 to infinity. Bottom up. Is this function increasing or decreasing? Increasing. Increasing, right? We read it left to right. What else? Oh, is the rate of change constant or variable? Variable, right? So it depends where I'm asking you. So like if I'm asking you from here to here, that's a different slope than here to here. So it's variable. It just means it changes. All right, last one, and this is basically, you can see there's not much new anymore. Quadratic. We haven't looked at quadratic in a little while. Who can raise their hand? Give me the vertex of that.
Oh.
Here, go for it.
Negative 2.
Mm-hmm.
Negative 9.
2, negative 9. Beautiful. It's that little guy right here. Who can raise their hand? Give me the axis of symmetry. Naija.
Is it 0 and 3?
Not the axis of symmetry. It's the equation.
Oh.
In the equation?
Mm-hmm.
Oh, x equals 2.
X equals 2. Remember, it's your axis of symmetry, your x coordinate of your vertex.
I know the y-intercept. I can't see that.
It just says x equals 2.
Nobody cannot see me.
The zeros. Who can raise their hand? Give me the zeros, Kayla.
Negative 1, 0,
Who? You're right the first time.
and 5.
Negative 1, comma 0, and 5, comma 0. Remember, roots, zeros, x-intercepts. Do you remember that opposite day thing too? So factors, remember factor form? Factors are just the opposites. What's the opposite of negative 1? Remember this, x plus 1? What's the opposite of positive 5?
Negative 5.
Remember that? Standard form. What's standard form of the equation? Y equals ax squared. You guys just probably wrote this on the test. Plus bx plus c. But c is always your y-intercept. Where is your y-intercept here? Negative 5. So I'm going to just put minus 5 for my c. So remember, c is always your y-intercept. What's the domain? Beautiful. Negative infinity to positive infinity. And what's the range? It's to infinity, but it's not at negative 5.
Oh,
It's the negative 10.
negative 9.
Negative 9. So right here. Because that's the smallest, and it touches it, so it's a bracket. So it goes from negative 9, that's the smallest y, all the way up to infinity. Now, this is one you guys forgot a lot when we were learning it. Increasing and decreasing
Uh-huh.
for this one.
It's increasing.
And so it might make more sense now that we've gone through all the other units.
It's increasing
Increasing.
because you know how the
Negative Nancy, positive Patricia.
So that, yeah, so that's your leading coefficient. Your leading coefficient is positive. But when we look at this, it's decreasing and increasing. Remember that?
Yeah.
So it's decreasing, remember I'm drawing it, it's going down, down, down until this point.
You decrease the negative now,
Might not.
then go up. So
But what's that x coordinate? I mean the x
Two.
coordinate. 2. So it's decreasing when x is smaller than 2. Then it's when x is bigger than 2, it starts increasing again. See that? So you can even do from negative infinity to 2, it's decreasing up until here, and then once it gets to 2, it starts increasing. Either way, you want to work. Does this have a variable rate of change or a constant rate of change?
Variable.
Because it changes. So like if I'm doing this rate of change, that's different than this rate. So the rate of change is variable. So this is like a little cheat sheet too. So you'll be able to use that. I'm going to go through one example all together with you because some people got confused with this. We are collecting this as a strategies grade. Most people were able to get 100 on it if they were paying attention. If they're not, it was like another thing, a 0 or a 100 sort of scenario we had here. So you're going to this worksheet right here that has like 9.5 comparing characteristics. It looks hard, it's not. So we're going to start with the first one, which is f of x, that blue equation. What type of equation is that? Linear. So I'm going to go to this part of it, and I'm going to write linear. What is always the domain when it has arrows? Negative infinity to positive infinity. Half of your strategies grade is filling this in. And I would say 50% of last class was so mad because they didn't fill this in when they're supposed to, and this is half your grade. So if you're filling it in, that's a 50 right there. Your range, if it's going down forever, not forever, what is it? Yep, the positive. Do linear equations have an asymptote?
No.
Nope, so just cross it out. Looking at this equation, is it increasing or decreasing? Yeah, see how it's going down? So it's not increasing, it's decreasing. And behavior you can skip for right now. We'll do that tomorrow. Y-intercept. What's the y-intercept?
3.
How do I write that as a point?
0.
0, 3. Now, this is what everyone was a Strug City with. 0, 2. But the rate of change for constant is always constant, right, for linear? So what's the slope? What's the slope of that equation? You can just look at the
Negative
equation.
2.
Look at the equation.
1.
Oh,
Ooh,
negative. I
it's
see
right
that.
there.
1/2. Negative
Negative
1/2.
1/2. It's right there, right? Or I could sit here and go, okay, from here to here, I go down 1 over 2. Either way, you get the same answer. So negative 1 over 2. And then we have to do this last part last. Cool. That's a third of the way done. Let's go to the next one, g of x, which is this parabola. What is that? What kind of function is that?
Wait, which
The,
one?
the parabola, the one that goes like this. Quadratic, right? So I'm gonna write quadratic right here. What's the domain?
Negative infinity.
Now let's see if you can get the range. What's the range of this?
Ooh.
Beautiful. Does everyone get that?
Yeah.
The lowest is negative 5 to infinity. So negative 5, it touches it, so it's a bracket. But is there an asymptote in quadratic? Is it, now we need to figure out what it's increasing and decreasing.
Increasing.
It's doing both.
It increases when it hits 2.
Yeah, so after 2, it's increasing. See that? Once it hits 2, it starts going up.
Uh-huh.
So when
How
x,
is it decreasing when X is
when x is less than 2, when we read it like this, see how it's going down up until here? Come on, like right here. It's going down until it hits that point, and it bounces back up. So when it goes down, when x is less than 2, it's decreasing. When x is greater than 2, it's increasing. So to do that, you always just look at your axis of symmetry. So it's either decreasing or increasing after or before that. What's your y-intercept of that parabola?
2, 3.
It's right. You might not be able to see it. It's right here. -1. So 0, -1. And then this is where everyone struggles, rate of change. So all you have to do is you look on the graph, or you could plug it into the equation. You guys are forgetting rate of change a lot. We did it for the last 2 units. But rate of change of this, I look over here, and I find where, if it looks like this, 0 and 2, right? It's when my x is 0 and my x is 2. So I'm looking right here, and I find where that function 0, which is right there. Then I find where the x is 2, which is right there. Then you just do rise over run. So how much is it going down? 1, 2, 3, 4. Over 2. Down 4, over 2.
Oh. -2.
So your slope is -2.
Is it 0, -2, or is it -2?
No, -2 because it's a slope, not a point. If I were doing it with the points, this point is 0, -1. This point is 2, -5, and I could find the slope, which would be the exact same thing. Either way you want to go. Cool. So my rate of change is -2. Cool. Last one. What's that third equation called?
Exponential.
Yes. The third one is exponential. What's the domain?
-2.
What's the range?
To
It is the positive infinity. But what's the lowest y?
Lowest 3.
-3. Good. So it's -3 to infinity. Does everyone get that? Because you look at
what is
the
asymptote again?
at and rear end where it's ending. Like right here is the asymptote.
Oh.
Good. X equals -3. The range is just like, okay, it's going from your asymptote up. So right here it's going from -3 to infinity. Your asymptote, yes, is -3. Larry's right. Is that function increasing or decreasing? Increasing. Yep.
Y equals 1.
Is it? No, it's X. Right?
Huh?
No, all the Y's, right? Horizontal point.
Oh, shoot.
Is it X or Y?
Y. It's not decreasing. What's the y-intercept?
2,
Good. 0, -2. And then the rate of change, if you like doing it from here, you just, okay, here's 0, and then at 2 it crosses right there. So how much do I rise?
3.
1, 2, 3. Good. And then over how many?
2.
2. So it's 3 over 2.
3 over?
Because it rose 3, ran 2. What's one similarity they all have?
They have the same domain.
Yes.
They don't have a fraction.
Same. Well, this one's -2 though. Well, it's -2/1, but you can put anything as a fraction. They're all rational. Remember that? They're all rational. So, but the same domain is the most obvious one. What's one difference?
The formula.
There's a million differences.
The y-intercept.
Different y-intercepts, different
Different
ranges,
functions.
different types of functions, whatever you want to write. I'm gonna write different ones. Cool. Does that make sense? Nothing new. All right, so we are giving you 15 minutes, and you're just doing the second version of that. So like on the next page, God bless you. So if you just copied that all down, you already have a 50. So now the second half of it is just trying it on here. If you're one of those people who like it color coded, I have the actual graph up here so that you can look at it. So I am going to put a 15-minute timer on, and we are collecting that sheet. Yeah, just that sheet. We are collecting.
I need to sleep.
Okay, so we're gonna put that timer on.